In our last video, we talked about ways. We said that ways were collections of nodes, so let's draw that. Oops. Let's draw our map, and we'll draw some nodes in a way. So we've got our way here. It consists of 4 nodes, and we said in our last video that nodes were ordered, so let's order them. And here we have, again, 4 nodes. We said that a node could represent a node was essentially a line, and it could represent a road, it could represent a river, a fence, anything that we would normally represent with a line. And we also said that the nodes, again, were ordered, and that ordering had 2 purposes. The first was that it affected the shape. So we had our other example where we had 1, 2, 3, 4. So the order, I'm sorry, oops, the last one shouldn't be there. So that's today's lesson. The order in which these nodes appear in the way will change the shape. We also said that the ordering of the nodes would also change the flow, the implicit flow of traffic. So traffic could be in a road or water movement on a river. And so in this example, the direction is downward. And this order, this flow is implicit in the ordering of the nodes. So this is great for anything that we need to represent as a line, but what about things that need to be represented as a polygon, such as a lake, or a town boundary, or a city boundary, or the country, or any kind of, or building trace, for example, a building outline. So how would we represent that in OpenStreetMap? Well, it turns out in OpenStreetMap we represent those polygons as ways. Just the same way we do with lines. The difference is that in a polygon, the way is closed, so we call that a closed way. And the way that looks is I'll draw 4 nodes here, and we'll order them 1, 2, 3, 4. And the node consists of these 4 ways, but it also then intersects again with this first one. So it's the first and the fifth. So that's important that these are actually connected. So let's just do that again with a different object. And again, it goes back to the first one. That's how we know that it's a closed way. If it wasn't, if it didn't intersect with the first node, then it would just be a regular way. It would not be a closed way. Now, you might be wondering, in our previous example, we had we sort of ID'd, we gave these nodes identification based on their order in the way. But in actuality, all objects in OpenStreetMap have their own unique identifiers. They have their own IDs within the system. So the ordering that we've been doing, this numbering, is just for our own convenience. And so what I want to do is actually give a more realistic example where we have, I'm going to move this out of the way, oops, where we have nodes that have IDs that are not related to the order, just to illustrate the point. So we'll say this is node 500, 501, 502, and 505. So in this way, we'll start with 500, go to 501, 502, 505, and then back to 500. So the order that these appear in the way is 500, 501, 502, 505, and 500 again. So this way contains 4 nodes, but it actually, the ordering is 5 nodes. So 1, 2, 3, 4, 5. And that's going to be important as we think about more complex objects later on. So again, we can represent polygons or areas. We would also call these areas. So let's write that down. Or closed ways, just the same way we do with lines, except that it intersects at the first one. And we also said that nodes have identification, they have ID numbers associated with them that are independent of the ordering in which they appear in a way. It's also good to know that the ways also have identification, have IDs. So this way here might be way 20, right? And that represents the way, not the individual nodes. So way 20 contains 4 nodes, 500, 501, 2, 5, and 500 again, but it actually only contains 4 nodes, but the ordering is this 500. And we said that in the last video that the way this is represented in the computer is actually as a list. So this table here is a very accurate representation of how it's in the computer. So it's 500 to 501 to 502 to 505, and then back to 500. And that's how this shape looks inside the computer. And again, we'll need to know this for some of our later concepts. So just wanted to cover that before we got too far, and I'll see you in the next video.